Let's talk about the synthesis of esters. We're going to be only focusing on one type of making the ester. That's the most common way of making esters. It's also called a Fischer esterification. And it's usually done by adding in a carboxylic acid. So this is your acid group right there with an alcohol. So you put those two together, and an alcohol and an acid in the presence of a strong acid, and you have to heat it up to make a ester. Now this is also called a condensation reaction because it's going to produce water along the side. So it's going to make, you're going to combine two molecules to make a bigger molecule, and it's going to eliminate a very small molecule. And sometimes it eliminates water, and sometimes it eliminates alcohols, and those are called your condensation reactions. Now, the best way to look at it, how this really works, I can say that you're going to make water, and the water is always going to be made from those atoms. So you're going to get the OH from the acid, and you're going to get the H from the alcohol, and that would make water. And whatever is left behind, you're just going to get those together. So alright, so I'm going to go ahead and have this, okay, so have this as it is. And then you're going to make a new bond between that green oxygen and that carbonyl group. So I'm going to change the color there, maybe show the new bond that's made between with the pink color here. Okay, and then you just put down the other part of the ester that's coming from the alcohol. So that's going to be the O, and then the OCH3. So this part right there is coming from the alcohol, and the other part right there is coming from acid. And this is the new bond that's made between the alcohol and the carboxylic acid to make the ester. So it's also called an ester bond. Okay, so then let me take actually a real example where you will appreciate the formation of ester a little bit more. Let's suppose, I'm not going to change different colors, I'm not going to use different colors here. So let's suppose I got this salicylic acid. So this is a salicylic acid, and you're trying to make aspirin out of it. So what all I really got to do is just use an acetic acid here in the presence of a strong acid, and you heat it up. So this triangle is the sign for the heating up. And what you're really going to be doing is you're going to grabbing, change the color here, you're going to be grabbing this hydrogen here and these two hydrogens here to make water. And what's going to be left behind is going to be making the aspirin. So let me just copy this down here. Put that down there. So let's erase part of it. So this is called an acetyl. So remember, this particular green grip is called, yellow grip is called an acetyl. So it's going to be an acetyl salicylic acid. Or another name for that is an aspirin. It's a pain medicine that's used a lot. And then, in addition to that, if I use, so I'm still using the salicylic acid, and now if I use methanol, so CH3OH, so this methanol is going to get combined with the carboxylic acid that you have on the salicylic acid. So this OH right there and this hydrogen right there, they're going to get combined to make water. So I think I forgot to write down the O there. And then the rest is going to get combined, so I can copy this down here. So then I have an OCH3 there. And this is going to be making a new bond. So this particular bond right there is going to be a new bond here. the name of this compound would be methyl salicylate, and the common name for this is wintergreen oil. It's used to reduce the soreness because it can easily pass through the skin, and it can soothe the muscles that are sore in the body. So that's how you're going to be making esters. So be able to recognize what's the alcohol and what's the acid, and how you're going to put together to make the ester functional group. Now you can also hydrolyze the esters. So the way you hydrolyze the esters is you're going to be using the water as your reactant now. So the difference between the hydrolysis and making the ester is just the reaction conditions. You don't really use any water when you're making the esters, but when you start using the water, the reaction will go reversible and it will break up to make the carboxylic acid and your alcohol. So in this particular case, if I just copy this down, when you break this up, you're going to have an OH group attached to it. So that makes the carboxylic acid. And then plus, you're going to have your alcohol right here. So remember, both of those, the OH right there and the H right there, it's actually coming from the water molecule, so you can see with the color combination there. So you break it down to the acid form and your alcohol. So you make two organic compounds when you break down this ester. So that's called the hydrolysis of ester. Now you can also hydrolyze the esters under the basic conditions. So let's assume I'm doing this particular reaction, but now I'm doing under the basic conditions. So I could use NaOH as my base, and I'm still going to be heating it up. So when I'm using this as an NaOH, I'm using the NaOH, I'm not going to be making the acid at the end. So the difference between an acid catalyzed and base catalyzed hydrolysis of an ester is what the end product is going to be. So in case of your acid, let me just copy that down here. You're just going to be making a carboxylate ion there. So you're going to have an O minus there. And I could probably just kind of write down the Na plus. And then plus your alcohol is still going to be the same because alcohol will stay in the protonated form. So that part of the molecule will stay the same. So that's the difference between an hydrolysis of an ester under acidic and basic conditions. And when you hydrolyze these esters under the basic conditions, these are also called saponification reactions. So this particular one is called an saponification reaction. Alright, so we're going to keep things very simple in this video here. We're just trying to make the ester and hydrolyze the ester, and keep in mind the formation and the hydrolysis of the ester goes both ways. So if I go ahead and write down maybe one final reaction here, so suppose I have this as my ester, and I can hydrolyze this ester by using water and acid and obviously heating it up. And when I do that, it's going to make a carboxylic acid and an methanol. But then at the same time, if I reverse these conditions, I can go back and make the ester. So to make the ester from these, I want to make sure I don't use any water. It's just going to be the acid and you heating it up. And the most common acid is the sulfuric acid. And obviously it's not, you're only not limited to the sulfuric acid, but you could use other acids as well. So know the reactions is going to be reversible. Know the common name. And if you have any questions, feel free to leave any comments in the section below.